So we're doing these practice problems. We're going to talk about, you need to know the derivatives of the 6 trig functions from memory. You need to know product rule, quotient rule, chain rule. We'll see some quizzes on that on Monday and Tuesday next week. So we're going to practice some of that here. If you're watching the video, you might want to pause it because I'm just going to go ahead and work it. They've already worked it at the board. So the derivative of tangent. So this is, we're thinking of this as tangent of u. And so when we differentiate it, we're going to get secant squared u, and then times du is our chain rule part of the derivative. So the derivative of tangent is secant squared. We'll leave that inside function alone, and then we'll multiply that by the derivative of the 3x squared, getting 6x. Generally, we want to write the 6x stuff in front of the trig function, and so our final answer is going to be 6x secant squared 3x squared. Same thing, the derivative of secant is secant tangent. So we're going to get secant of u tangent of u times du, and the derivative of the 5x gives us an extra constant of 5. We write that out in front, so we write our final answer as 5 times secant 5x tangent 5x. So cotangents, the derivative is a negative cosecant squared of e to the x, and then times the derivative of e to the x gives us an extra e to the x. So we'll bring that out in front, so it'll be a negative e to the x cosecant squared of e to the x. For cosecant, it's a cosecant cotangent, a negative cosecant cotangent. So you get a negative cosecant x over 3, cotangent x over 3. The derivative of x over 3, we want to be able to see that as just the constant 1/3 times x. And so the derivative of a number times x is going to be just that constant. It's just a 1/3. And again, we'll bring it out in front, so it'll be a negative 1/3 cosecant of x over 3 cotangent of x over 3. Notice that in all of these trig derivatives, whatever the angle was to start with, whatever is inside there, that stays inside all of the trig functions that appear in the derivative. An easy mistake when you're starting out is I think you're just so worried about trying to remember what the derivatives of the trig functions are. I see a lot of times, like especially like on a secant tangent, I'll see a secant 5x, and then the next one just becomes an x. They call it a tangent x. So these kind of just a check at the end, all of your angles should agree. So there's not 2 different angles that appear anywhere in that answer expression. Questions on that? Okay. So I'm going to give you some then with a product rule and a quotient rule, and we'll do the same thing. I'll put it up there, and then I'm going to pause the video, but we'll come back up to the board to do those. Can I erase just the top row? Okay. So we're going to find the derivative of, and let's do, so f of x is going to be, actually, we're going to find f double prime on this first one. So let's go x squared times sine of x. So we're going to find the first derivative, which is going to be a product rule. So you're going to get 2 things. Then you're going to find the second derivative, which will be 2 product rules. So it'll kind of expand and grow. And then we'll do g of x is going to be, let's do sine x over 3 plus cosine x. And so this is going to force you to use the quotient rule. So you're going to do product rule, quotient rule, and then have to know the trig derivatives as part of that. Okay, come on up to the board and do that. I'm going to pause the video here. So we have product rule, so we're going to get prime of x first. That's the first times the derivative of the second, plus the second times the derivative of the first. So there's the first derivative. To get the second derivative, we're going to get the product rule on each of those. So we have the first x squared times the derivative of the second, which is negative sine x, plus the second cosine x times the derivative of the first is 2x. Then we move to this one. We have the first the derivative of sine is cosine, plus the second times the derivative of the first. So we have a couple of like terms here. The 2x cosine x is combined to be a 4x cosine x. The negative goes in front, so it's a negative x squared sine x. And then we just have the tag along to sine x. Okay? Got a quotient rule there. I'm going to pause it and you can give that a shot. So we're going to do the quotient rule. So we have, I don't even know what I wrote down. It looks like an S. That's prime of x. I think it was supposed to be a G. That's going to be G prime of x. So we have the denominator, b plus cosine x, times the derivative of the numerator, minus the numerator, times the derivative of the denominator is going to be 0 minus all over the denominator squared. So we'll clean up. I'm going to distribute. It's going to be 3 cosine x plus cosine squared x. That's going to become plus sine squared x. And still over the 3 plus cosine x squared. We're seeing our favorite trig identity. Sine squared plus sine squared plus cosine squared is 1. So we're going to get 3 cosine x plus 1 over 3 plus cosine x quantity squared. There is our derivative. Okay, how are we doing? Good. So I'm going to go ahead and finish up there still. I'm going to do a 3-link chain with you first, and then I'll have you come to the board to do a different 3-link chain rule. So we are going to say y is equal to, let's do the cotangent to the 4th of 3x squared. So there is our 3-link chain. So what you try to be able to do is see a function inside a function inside a function. So this is the composition of 3 functions. So the innermost function is what? The 3x squared. And that's inside the second function, which is the cotangent, which is inside the third function, which is the 4th power, x to the 4th. So we are going to work our way outside in. Okay? So differentiate that outermost layer, leave everything else alone, move to the middle layer, multiply that by that derivative, and then get to the innermost layer. So our dy dx, since the outermost one was the 4th power, we're going to do what? 4 cotangent to the 3rd, and everything else stays the same. So now we're done with that. So we're going to multiply them by, what's the next layer? What are we going to differentiate next? The cotangent. And the derivative of cotangent is?
Negative cosecant squared x.
Nice. And u. 3x. So in this case, the 3x squared. Yeah. Right. So negative cosecant squared of u, whatever that may be. So then we're down, we've done the middle layer. Now we're down finally to the innermost layer. And that, we're going to differentiate the 3x squared to get 6x. So our calculus is done. We'll do a little bit of simplification. Anything that's not a trig function is going to migrate to the left. So the 6x, the negative from the negative cosecant squared, and the 4 are all going to combine to be, I think, a negative 24x. And then we've got our cotangent cubed of 3x squared, and our cosecant squared of 3x squared, and that's our final answer. There's our derivative. So you get to try one now. So we will do y equals, and we will do secant to the 3rd of 5x squared. And we're going to find that derivative. So here's what we got, our 3-link chain. We're going to, for our derivative, we're going to do the 3 secants to the 2nd. And everything else stays the same. So that's the outermost layer, the cube, the x cubed or u cubed. Now we're to the secant level, and derivative of secant is secant tangent. So it's going to be secant of, and tangent of the same things. So notice all of the trig functions have the same angle. Then finally, we're to the innermost one, and that's going to be a 10x. So now the calculus is done. The 10x is going to join the 3 to become 30x. We have a secant squared and a secant, so we're right back up to a secant cubed again. And we just have a bunch of extra stuff too that we didn't have before. Okay, so we are going to now take a look at this worksheet. It's on Canvas. It's on the chain rule. So I'm going to pause this for a minute. We'll talk a little bit. I'll come back and join you. If you're doing this at home, I really think it's a great exercise to do with somebody else so you can talk about it. There's some great discussion that needs to come out of that. So I'm going to pause the video here. Okay, so looking at part A, h of -2 is f of g of -2. So g of -2, you're going to go to the graph and you're going to look, and it looks like it's about how much? 4 maybe. And then f of 4 will go to the graph, and it looks like it's about, yeah. So some people get mistaken. They think it's going to be -3 because they can see the dot, but when you see the dot, it's not really on the line. You can't see the -2 because the line is covering it up. So that's an exact one. So that's at -2. Okay, and then h of 1, well, these are not B and C yet. So h of 1, we're going to get f of g of 1. And so g of 1 is about 0, good. And f of 0 is 0. So that one's going to be 0. Nice. And h of 2 is going to be f of g of 2. And g of 2 is going to be pretty close to -2. And f of -2 is going to be about, and there again is the one that you can't see because it's behind a line. So it should be 6. Okay, now we're ready to tackle part B. H prime of -1, is it positive, negative, or 0? And justify. So I'm going to pause the video. We can have some robust discussion. Hopefully on here. So we're finding h prime of x, which is a chain rule derivative. So we're going to take the derivative of the outside function, leave the inside function alone, times the derivative of the inside function. So we want these all at 1. So we want f prime of g of 1 times g prime of 1. So g of 1, it looks like is about, what, 0? Does that look right? And, oh, at -1, I did the wrong. Should be a -1. Hold on there. -1. So change that's -1, -1. So g at -1 looks like it's about 1, 2, 3, between 3 and 4. Does that look right? About 3.5 roughly. And this is going to be a -1. So all we're interested in is a sign. So when you go to 3.5 on the F graph, that's going to be where it's decreasing. So the derivative here is going to be a negative. And on the G graph at -1, it is also decreasing, which means it's going to be negative. And then since those are multiplying each other, we're going to get positive. So our answer there is going to be positive. Okay, I'll let you try that on part C, and I'll pause the video again. Okay, so on the first one, h prime of -2, since our derivative, our chain rule derivative is up here, we're evaluating everything at -2. So g of -2 looks like it's roughly 1, 2, 3, 4. So 1, 2, 3, 4 approximately. So we have f prime of 4 times g prime of -2. On the F graph at 4, it looks like it's decreasing, so it's going to be a negative. And g prime at 2 looks like it's also, am I doing that right?
It's
G G prime at negative 2. I was looking at 2. That looks like it's right at the part where it's the top of the graph, the peak, where it's horizontal, which would make that 0. Is that what you thought? Okay, good. So then if we do the at H prime, we're going to get F prime of G of 1 times G prime of 1. So G of 1 is 0, so this will be F prime of 0 times G prime of 1. At 0, well, looks like again we got a horizontal tangent, so that's going to make it 0 again. And then on the H prime of 2, we are going to get F prime of G of 2 times G prime of 2. And G of 2 looks like it's about negative 2. And so on the F graph at negative 2, it's decreasing, so it'll be a negative derivative. And on the G graph at 2, it's also decreasing, so it's going to be a negative, which is going to make that positive or greater than 0. Okay? All right, try D. Remember, it's still a chain rule derivative because your K is F of X to the 4th. So I'll give you a shot at that one. So to find K prime of X, well, increasing, decreasing means we need to know what the derivative is. Positive derivative means it's increasing, negative derivative means it's decreasing. Now, K prime of X, remember, it's a chain rule derivative. So we're going to get the derivative of the outside function, leave the inside function alone. But then we're going to have to multiply by the derivative of the inside function. That's easy to overlook. So when we evaluate K prime at negative 1, we're going to get F prime of negative 1 to the 4th power is positive 1. Negative 1 cubed is negative 1. Times 4 is a negative 4. All that really is going to matter is the negative sign. When you go to the F graph at 1, it looks like that is increasing. So we're getting a positive times a negative, which means that's going to be negative, or we could say K prime of negative 1 is less than 0. It's a negative. Follow reasoning?
Answer if it's increasing or decreasing.
So then we would say it is decreasing. Sorry, good question. Okay, so it's not enough to say the derivative is negative. You have to answer that question. K is decreasing on that interval containing negative 1. Okay. Let's do some more practice of trig functions, unless there's something else somebody wants to practice. So just for old time's sake, let's do our product rule. Product rule is the first times the derivative of the second plus the second times the derivative of the first. The quotient rule is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. The product rule is the first times the derivative of the second plus the second times the derivative of the first. The quotient rule is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. The product rule is the first derivative of the second plus the second times the derivative plus the denominator. Stay on beat, Tim. The quotient rule is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. We got work to do. Okay.
I just can't.
I know how to do it. I think of it different.
I think I got it.
I think of F of X over G of X.
Oh, okay. So let's do, let's see. We'll throw in, we'll do a little product rule maybe together with a little chain rule. See what we can do with that. So we got x to the third times cotangent of 5x cubed. See if we can find F prime of x.
Squared.
Yeah.
Cosecant squared.
in top?
I'm good. We're using the chain over here.
No, we're using the top.
Oh, okay. It's fine. Oh.
You forgot us and then you forgot me. Forgot them.